Yes, the world better be afraid. Japan, the United States, and the United Kingdom have all teamed up to develop a single 6th-generation fighter, which would give particularly China and North Korea something to worry about. This fighter, belonging to the Japanese Air Force, is known as FX, and boasts features never before seen on a fighter jet, thanks to an interesting development story that began as soon as the US banned exports of the beastly Lockheed Martin F-22 Raptor, even to ally nations. With Japan no longer able to purchase the trailblazing 5th-generation F-22 Raptor, thanks to the 1997 Obey Amendment that sought to safeguard the Raptor's technology, Japan's Ministry of Defense spent $23 billion on acquiring 2 squadrons of the F-35 Lightning II, but also realized it was about time they had some fighter technology of their own that's worth safeguarding. And so a domestically developed fighter was chosen as the route to go. An informed, intelligent, and instantaneous fighter that would be a generation ahead of the contemporary 5th-generation fighter and cement Japan's spot as a top world power once again. But being the new kids on the block in terms of developing a fighter more advanced than the 4th generation, Japan started off with a $350 million demonstrator, known as the Mitsubishi X2, to prove early on that the capabilities they wanted for their future fighter were indeed possible, to prevent getting stuck deep into the development of a 6th-generation fighter that would be more of a symbol of weakness than anything. The X2, however, would smash through its tests from its first flight in 2016 to 2018 when the tests were concluded, allowing Japan to obtain new information, develop new technology related to the FX fighter, and begin the FX program itself with the Japanese company Mitsubishi as the lead manufacturer. But they weren't going to do it alone. There's simply too much writing on this to leave it in the hands of a domestic firm that hadn't done anything similar before. And so, Japan sought international collaboration on the FX to help bring every detail they had evaluated during and after the X2 tests to life, from the radome on the aircraft's radar antennas to the thrust vectoring nozzles on its engine. This led to the Japanese government sending out proposals to the US and UK, who both have 6th-generation fighter programs of their own, seeking out their participation in the FX project. Boeing, Lockheed Martin, BAE Systems, Northrop Grumman, and the British government all responded to the proposal, only to have all of their response offers rejected and shut down by Japan, as they were considered unappealing enough, even though the UK offered the possibility of collaborating the FX project with their 6th-generation Tempest program, and Lockheed Martin offered an F-22 F-35 hybrid fighter, a fighter which even the United States doesn't have. In Japan's defense, though, you don't make a 6th-generation fighter by combining 2 5th-generation jets. However, collaboration with foreign defense contractors was still very much an option for Japan, but only if the contractors could work towards Japan's 5 key aspects for their future fighter: capability for future air superiority, potential to expand capability by incorporating next-generation technologies, ability to upgrade and modify the platform with relative ease, participation of the Japanese industry, and lastly, affordability. With Japan clear as day on that, Lockheed Martin qualified to provide technical assistance while talks went on with Britain's Rolls-Royce to provide the jet engine as Mitsubishi works on the airframe design and system development, all expected to come at a cost of about 5 trillion yen, or $48 billion. So far, all signs point towards a fighter that will be packed full of the most advanced fighter technologies of 3 of the most powerful nations in the world, as is clearly hinted at in the features of the FX fighter. The FX fighter is designed to be a twin-engine stealth fighter for air superiority, with capabilities and technologies developed in the present for the future, starting with its electric actuators. Electric actuators will be applied to the fighter's control, power, and brake systems that will see it do away with conventional hydraulic systems, for understandable reasons. Electric actuators are, thanks to an electric wiring connection, flexible enough to fit into complex interiors of the fighter, giving developers the freedom to design the jet as is most efficient. The electric actuators also come with the added benefits of making the aircraft more mobile and lightweight. Despite its large airframe, the FX is looking to maintain a lightweight body without hitting the gym. Its approach instead is eliminating the use of fasteners by bonding composite materials together through adhesive molding, and using this across the entire fuselage of the craft. Aluminum alloys and carbon fiber reinforced polymer, or CFRP, are used across the fuselage, being better lightweight options, allowing the fighter to adopt new design methods that can reduce the structural mass of its airframe by 11.6% in 66% less time than conventional methods. To protect these materials from the certain heat from the engine and avionics that would definitely riddle the fighter, a heat shield is placed around the engine to protect the aluminum alloys and CFRP in that area, while the air cycle and liquid cooling systems are assisted by a dedicated heat transfer system installed in the fighter's avionics. The EMP-resistant fiber optic fly-by-wire avionics and self-repairing flight systems that detect and automatically compensate for damage to the aircraft's control surfaces are some of the new technologies tested on the X2 that are likely to reappear in the FX. The fighter would also feature integrated sensors for improved detection against stealth aircraft, including a highly sensitive infrared camera, an active electronically scanned array or AESA radar, and a radio frequency RF self-defense sensor, which, like the AESA radar, utilizes gallium nitride to improve its performance. The result of all of these is a system alerted by body antennas in a timely manner to the threat of an opposition aircraft, air-to-air missile, or surface-to-air missile, and can respond with the appropriate countermeasures. To minimize its radar cross-section, the FX features serpentine air ducts and an internal weapons bay. It also employs carbon-based electromagnetic wave absorbers applied to these air ducts and its engine to reduce the amount of radar reflection while using passive detection to avoid having its own radar emissions detected. Then there are the metamaterials consisting of various materials including small pieces of metal and dielectric that are applied on the pulse Doppler system as part of a radio wave reflection control technology designed to do just that, reflect radio waves off the aircraft. And to reflect even more radio waves, the fighter uses plasma stealth antenna technology, which can double as communication hardware to create temporary plasma that exploits the characteristics of plasma to change its physical properties through electrical control. Japan is in talks with Rolls-Royce regarding the engine to be fitted on the FX fighter. But while that hangs in the balance, the FX is slated to be powered by two XF9 engines, each donating 24,000 pounds of thrust dry and 33,000 pounds with afterburner, with further development on the engines ongoing to get each one to produce up to 44,000 pounds of thrust. The XF9 also has a slim size relative to its power, which allows for more room for the internal weapons bay and stealth preservation without having to trade off thrust or power. And speaking of power, the XF9 has a large electrical power output of 180 kilowatts, giving the FX a total combined power of 360 kilowatts, more than enough power to feed the fighter's powerful avionics, its equipment, and the world. Okay, well, not the world, but something even more impressive about the engine is its three-dimensional thrust vector nozzles that can deflect thrust up to 20 degrees in all circumference directions, thrusting the supercruising fighter to a sky-high level of maneuverability. Literally. Thanks to its large size and spacious insides, the FX can carry up to 6 internal weapons, which doesn't sound like much, but it actually is a pretty big deal. And in addition to the long line of kinetic weapons expected of any fighter, the FX will be armed with a microwave weapon, much like a laser-directed energy weapon, to disrupt incoming missiles. This weapon is activated by the AESA radar on board, through the use of highly efficient electron tube amplifiers. The FX will further be armed by drones that serve as some sort of loyal wingman to the main manned fighter. These drones will be of 2 versions, and although they look like twins on the exterior, their functions will actually be quite different. One would be a sensor carrier that scouts for targets, while the other fires munitions and directs incoming missiles away from the main manned fighter. These drones are expected to be fully developed by the 2030s, around the same time the FX fighter itself is expected to be introduced into service to bolster the nation's defense industry, completely change Japan's defense posture, and prevent China or North Korea from subscribing to the notion of testing new missiles near Japan's borders. Speaking of subscribing, you definitely should subscribe to this channel and smash the thumbs up button below. They help with the development of the FX fighter for sure. That will be all for now. Thanks for watching.